I want to talk about transistors. Now, in your phone, you might have 2 billion transistors in your phone. These are discrete devices, the one that we're using. Discrete just meaning that they're individual components. They're not packaged into chips. There's two main types of transistors. There's a BJT, which stands for a bipolar junction transistor, and it's controlled by a small input current. And then there's a field effect transistors, which are controlled by a small input voltage. For example, MOSFET is metal oxide field effect transistor. We're going to be dealing with in Electronics 1. We only deal with BJTs, or bipolar junction transistors, and they're called bipolar because there are two junctions, right? Bipolar junctions, two junctions. We'll talk about that in a minute. This is what your transistor is going to look like, and this is the schematic symbol for your transistor right here. And this is a schematic symbol for what's called an NPN transistor. An NPN transistor. I'm going to show you how to determine the NPN from the PNP in just a moment. The transistor has three leads. It has an emitter, it has a base, and it has a collector. So a emitter, a base, and a collector. The emitter junction, the emitter pin, is always denoted by the arrow. That arrow can either be pointing out, or in this case, it can be pointing in. And that's what tells us whether we're dealing with a PNP or an NPN. And I'm going to show you how to identify that. So there are two main types of bipolar junction transistors. There is an NPN and a PNP. An NPN type consists of two N-type materials, so sandwiched between a P-type material. So look, this would be an NPN, NPN, N negative, P positive, N negative. That's an NPN, and in an NPN, the arrow points out. You can think of that in terms of looking at this arrow, because this is how you identify if this is an NPN or a PNP. We look at this arrow, and if it's not pointing in, it is an NPN. NPN, not point in. The arrow points out. It's pointing out of the circle. So that is an NPN, not pointing in. Let's take a look at a PNP. A PNP is a P-type material, so positive, negative, positive, so PNP material. Look at this one. The arrow is pointing in here. Kind of looks like if you were peeing into a pot. It looks like the pee is going into the pot. And there's an easy way to remember this, which one's which. The PNP points in, pee in pot, sort of like someone peeing into a pot. You remember it however you want to remember it, okay? So we've got P in P and NPN. NPN, not point in, PNP is P in pot. And the only difference really is the fact that the NPN has a P-type material at what's called the gate and a negative type material at the anode and the cathode. But we don't call them anode and cathodes. It is very much like two diodes that are connected like this. But we don't call that the anode and the cathode. We call it the collector and the emitter. Now, the one thing that we have to understand about transistors, so I'm going to say this here, the leg that has the arrow is the emitter. The leg that is all by itself, right? This leg coming in all by itself, that is the base. And this must be, by process of elimination, the collector. The rule is that in order for identifying polarity, like how do you bias these in a circuit? What is positive? What is negative? Well, we look at the center pin. We look at the center pin here, and that center pin is P, which is positive. That center pin is the base. So we know that we have a base on this device, which it needs a positive to function. Now, the rule is that for a transistor to work, the base to emitter junction, so the base to emitter junction must be forward biased, meaning that if this P-type material is positive. I put a positive there. I must have a negative here. So my negative would be that pin there. Now, the way a transistor works is kind of like this. We attach a circuit like this and an additional power supply over here. We adjust a little bit of current through here and we get current flowing and it flows up through here like this. So this must be, if this is negative, this must be positive. It must be the opposite to the collector. So this would be a positive. Okay, looking at this one, this is a PNP. So we know right off the bat that the arrow is the emitter. And we can take a look in this. This is the base. Okay. And this is the collector. So that's all the same. Now we notice our polarity here. This is a PNP. N is negative. So this must need a negative in order to operate. If this needs a negative and transistors must be connected forward bias, it means that the emitter must get a positive in this case. The base is getting a negative, and it must mean that the collector, therefore, is going to be a negative. Okay, so now we've been able to identify what these are made of. Well, we're going to look at a video in terms of what these are made of and how they function at an atomic level, but we've been able to identify how to identify the leads of a transistor. But we did have to make a couple assumptions. We did have to know, well, what's the base? Now, we might not always know the base. So let's take a look at getting to know transistors, how to ring them out. So if we look over here, so this first one over here in this red box, around this yellow box over here, look at this, we say, okay, what's going on here? I've got a couple connections here I'm making. So I've got a connection I'm making here on this meter on the left. It says 0.623, that's a volt. This is I'm checking number one. So I'm taking the red lead and I'm going up to this point right here. So I'm looking at the base. I'm going to the base here. And that's only because I know in this type of transistor, the center pin is the base. So, but yours don't look like this, okay? But I'm just showing you what to look for. So I'm going to put the red on the base and then this one here to the other pin. I don't know if that's a collector or the emitter. And that's what I'm trying to do is find out what is the collector and what is the emitter. So if I read it from this way here, I go, okay, look, I've got my red, which is positive, and I'm getting a value of voltage. So it means that I'm on the base, and the base is positive, so it must be an NPN. Now, I don't know which one's the collector and what's the emitter, but I know it's an NPN because I'm on the center material with a positive and I'm getting a reading. If I wasn't getting a reading, then I'd have to switch my leads around and put the negative on here, in which case I'd be dealing with the PNP. But I'm dealing with an NPN because I've got the positive on my base. Now I check my voltage. This is on diode check, by the way. And I check my voltage between these two pins and I go, okay, that's 0.623. Doesn't mean anything unless I have another one to compare it to. So I look at this one and all I've done is I've left I know it's a P positive type material on the base. So I'm going to leave that there. I'm going to take this black and I'm going to move this to the right-hand pin because I want to know which one's the collector and which one's the emitter. This one here, I'm reading 0.625. So 0.625 between this pin, which is the base, and this pin here. This one is 0.623 between the base and this pin here. Well, analyzing the results, we can make an assumption that the value of the voltage that is higher is for the emitter to base junction. It is the base to emitter junction.